So if we want to describe the general characteristics of logarithmic functions, again, keep the same track here, where what we can do is look at things like domains and ranges and get that the domain of f of x equals log base b of x consists of all positive real numbers because the range of an exponential was all positive real numbers, and the range of a logarithm will be all real numbers because the domain of an exponential was all real numbers. Then if we want to graph them, they're going to pass through the point 1, 0, because f at 1, which is log base b of 1, will be 0 for any base. And the function will not have a y-intercept because you can never have an exponent that gives a value of 0, for exactly the same reason that the exponential never crossed the x-axis. Then if b is positive, the function log base b of x will go up to the right and be increasing. If b is between 0 and 1, then log base b of x will go down to the right and be decreasing. And we have that there is a vertical asymptote along the axis x equals 0, that is the y-axis, because our function is going to be trying to touch that but never quite reach it. And on the other hand, if we want to describe our translations, we get the same sorts of things again, but just to be a little bit specific here, we would have things like vertical translations, pushing it up, pulling it down, horizontal translations with the c on the inside, pulls it to the left and right. We have reflections, so negative log b reflects about the x-axis, and log b of negative x reflects around the y-axis. C log b and log b of cx, those are our stretch and shrink terms. And if we want to think about what various pictures might look like, we can think about how those various things might affect the graph of a logarithm. Where one thing in particular I want to mention before we get an example is those reflection terms, g of negative log b and log b of negative x. We're not quite there yet, but we're going to see in the next couple of sections that those, due to the exponential nature of a logarithm, have some other very special ways that they can be rearranged. I don't want to get ahead of ourselves just yet here, but know that we will be seeing something in particular with that soon. Anyway, let's get one quick example here with how you can handle this sort of behavior in terms of graphs and domains. So for this, we want to find the domain of f of x equals log base 4 of x minus 5, and then graph it. So the domain of a standard logarithmic function, something like, let's say, the domain of log base 4 of x, that would end up being, well, just like we said in that last part, 0 to infinity. So if you want to find the domain of log base 4 of x minus 5, what we need to understand is that we are dealing with that horizontal translation where we are pushing the whole thing to the right 4 units. We're saying it starts 5, I missed that guy. We're starting 5 units to the right. So, as a result, we're not going to be able to cross the line instead of the axis, but at x equals 5. So we'll go from 5 to infinity as we are looking for the solutions to the inequality x minus 5 is greater than 0. We needed this guy to be bigger than 0. That means we need that guy to be bigger than 0. So that ends up being our domain. And accordingly, if we wanted to graph that, we would end up with a picture, something like so, which is just our general logarithmic graph pulled to the right to start 5 units late, with, importantly, that vertical asymptote. And from here, you might find yourself wondering, okay, this is a lot of different things you have to deal with here. Just like with exponentials, you can put any base in there and get a slightly different function for that value b. So you might think to yourself, wow, does that mean you have all these different logarithms for all the different bases, like 4 or 6 or 8 or 10 or like 12.0125? And the answer is yes. But meaningfully, there are only a couple that we really care about. And we'll get a really specific why really specific reason why. There are only a couple we need to care about later on, but for now, we should understand that there are two in particular that matter the most to us, things called common logarithms and natural logarithms, where those are what we're going to finish this section talking about.